Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss a typical question on Young's modulus from Cambridge AS Physics. Young's modulus is also called modulus of elasticity, and today's question is very important on this topic because this type of questions are very common in past papers. For this question, it is given to us that a student is investigating the mechanical properties of a metal and he has plotted a graph of stress against strain. The student also repeats the experiment with a wire that is made from the same metal, but its dimensions are different, its length is double and its diameter is half. We need to simply find out which graph he will obtain from these given four options. Actually, this question is simply based on Young's modulus. Let's try to understand what exactly is Young's modulus. Young's modulus is also called modulus of elasticity. Modulus of elasticity. Elasticity we need to understand because this is also a very important concept. It is called modulus of elasticity because elasticity is the ability of a material to regain its shape. If a material has higher ability to regain its shape, its Young modulus will be higher. If it has low ability to regain its shape, its Young's modulus will be lower. For example, Young's modulus of steel is higher than Young's modulus of rubber. Now let's try to understand what is the relationship between Young's modulus and stress and strain. Young's modulus is the ratio between stress and strain. So simply we can say stress divided by strain. So you can use Y or you can use E. Now, we also need to understand that Young's modulus is property of material. Like the resistivity, resistivity is a property of material that does not depend on dimensions. And same Young's modulus is also property of material. So first thing we need to understand is this is property of material. It depends on type of material but does not depend on dimensions. We will go to that point later. It depends on type of material. It depends on type of material. It simply means that let's say we have one wire, this is made of copper, and let's say we have another wire and the second wire also have the same dimensions, but this wire is made of steel. So the Young's modulus of copper wire in this case will not be equal to Young's modulus of steel because these are two different materials. And the second thing we need to understand about Young's modulus is that it is independent of dimensions. So it is independent of dimensions. What exactly it means by independent of dimensions? It simply means that let's say we have one wire and this wire is made of copper. And we have another wire and this wire is also made of copper. But for this wire this is L and for this wire L1 let's say, and this is equal to 2 times of L, and let's say the diameter of this wire this is D and the diameter of the second wire this is D by 2. Now these two wires, they are made of the same material. Even their dimensions are different, but Young's modulus for these two wires is the same because they are made of the same material. So it simply means that Young's modulus does not depend on dimensions. So it is property of material. If temperature is the same, Young's modulus is the same for a wire if the wire is made of same material. So if Young's modulus is the same, so we can also say that for the same stress, for example, if Young's modulus is the same and at the same stress, there must be same strain. So strain also has to be same. So from here we can simply conclude that if the wire is the same, so the graph we will obtain that also has to be the same. graph has to be identical. Even the dimensions of the wire are different because the student is using an other wire that has different dimensions but is made of same metal, made of same material, so Young's modulus is the same. For any value of stress in the wire, strain also has to be the same because Young's modulus is property of material. If the wire is same, Young's modulus is also same. This is our graph for first wire. You can see this is the graph for first wire. So simply we can say this is for first wire. This has to be the graph for second wire because these two graphs has to be identical. So this is graph for second wire. Graphs are identical. Why? Because it is made of same material. So our answer for this question is B.